Assalamualaikum warahmatullahi wabarakatuh. We'll continue chapter 3, which is stereochemistry. Stereochemistry is the study of three-dimensional structure 3D of the organic compound. This is we call how to draw the 3D structure formula of methane, CH4. And this is the ball stick model of 3D structure of methane. So this ball line shows the front of the atom or the structure. However, the dash line meaning the backward or back of the structure. In the stereochemistry, there are two classification isomer. Isomer, what is an isomer? Isomer, the molecular formula similar but different in a structure or stereoisomer. Structural or constitutional isomer and stereoisomer. Different structure and stereoisomer. In the stereoisomer, there are two types. The first one, we can differentiate between the geometrical isomer. Geometrical meaning the position of the branch, cis or trans, or a chiral and a chiral of the stereoisomer. So this slide shows the structural or constitutional isomer. Meaning the compound have same molecule or molecular formula but different in structure and different name. Example here we have one chlorobutane and two chlorobutane. There are similar formula molecular. Example carbon we have 4 carbon, 8 hydrogen, 9 hydrogen, 3, 5, 10 hydrogen and 1 chlorine. So the difference between them is the position of chloro position. 1 chloro at carbon number 1, while 2 chloro at carbon number 2. So for geometrical isomer, they can divide in this stereoisomer isomerism too. Can divide it into two kan geometrical isomer. For geometrical isomer divided into cis and trans. Cis meaning same side. The substituent tu the penggantian tu substituent is the same side. Example here, cis upper or lower side, the same side. Meaning if CH3, so the upper side, the carbon, second carbon attached with the methyl also in the same side, which is cis 2 butane. We call cis 2 butane. However, the trans opposite side, meaning opposite upper and bottom, top and bottom. Example here, methyl for the left upper or top, and for the right is bottom. So trans 2 butane, we call trans 2 butane. So geometrical isomer can divide into two, cis or trans. So this is a simple one. So stereoisomer, we can conclude that stereoisomer is the isomer that have same formula and connectivity but differ in the position of the atom in space. So formula sama but different in position. Stereoisomer divided into two, chiral compound and achiral compound. Chiral compound, any molecule that is non-superimposable with its mirror image. Example, we have right hand and left hand. Example, hand. So you have right hand and left hand. When you overlap, So chiral compound. Chiral compound, there are two stereoisomer, which is chiral compound and a chiral compound. Chiral compound is any molecule is non-superimposable with its mirror image, meaning A and B, we have a right hand and left hand, and when we overlap that our hand, it the structure is the our hand is non-superimposable. Example, our hand. So example, the right and left hand cannot be superimposed, or we call non-superimposable mirror image. So it is a chiral compound. Example here we have bromochlorofluoromethane. Bromochlorofluoromethane. So in this structure A and B, this is a mirror image. So it cannot be superimposed, and the atom attached at the carbon is different. Bromo, chloro, hydrogen, and chlorine is different. It is a chiral molecule. However, a chiral or non-chiral molecule, or we call a chiral, it is a superimposable mirror image. The mirror image too can be superimposable, chair or table, example. So, meaning each molecule has two identical substituents. Example, we have two atom H or two atom of methyl attached at carbon, or contain a plane of symmetry. Example, here we have a salt. Salt, superimposable mirror image. Therefore, they are identical. A pair of salt is said to be a chiral, tapi a pair of soap cannot. It can two soap can be overlap, man, right? Soap punya stokin can be overlap, but not a chiral. A chiral cannot be overlap. A plane of symmetry example, we have chair. Half of chair can be overlap, so it is a chiral. So when half molecule to reflect each other a half lagi. So example, the structure or atom is molecule is bromochloromethane, a chiral molecule. And now you can see we have the first thing you identify first. Atom, now we have 2H. 2H at carbon, a similar carbon. Or when this is a mirror image, A and B is a mirror image. When B, we rotated 180 degree, it becomes C. So C and A is a mirror image. And also can be superimposed, or we call identical mirror image. So this is the difference between chiral and achiral. First, mirror image. Chiral non-superimposable. Achiral superimposable. Molecule pula and enantiomer have opposite configuration. And however, achiral is identical. Tips to remember? Remember chiral molecule carbon attached to different groups. Example, we have methane. So carbon can be attached for group or for atom or for molecule. Different. Each of the group that attach at the carbon is different. A chiral identical. At least we have two similar compound. Example, previous slide, there are two hydrogen atom. This hydrogen atom. So we call a chiral. So I want you to answer this slide. We have a structure A, B, and C. Classify the following compound as a chiral or chiral. Please comment at this video and answer A, chiral or achiral or non-chiral. A, B, and C. This is your homework. I want to see the answer. Just comment in this following classroom.